like as sine function, when we restrict domains and codomains of cosine function, tan function and other trigonometric functions, then we make them bijection and then only we get their inverses. So if we restrict their domains, then this is the situation for function and the domain. So I am writing that is function, that is domain, and here principal value branch. Starting from sine inverse, its domain is -1, 1, and its principal value branch is, that is close interval -π/2 to π/2. This is about sine inverse x. When we take that is cos inverse x, then its domain is -1 to 1, and here restriction is 0 to pi. Its branches are, for cosine inverse function, branches are 0 to pi, pi to 2 pi, 2 pi to 3 pi, and so on. And for this domain we say it is principal value branch. If I write that is tan inverse x, so its domain is set of real numbers and principal value branch is, that is the same sign but excluding it, -π/2 to pi. Now cot inverse x, that is domain is r and its principal value branch is 0 to pi. And next one is sec inverse x, and it is minus open interval -1 to 1, and here that is close interval taking same interval for cosine, that is 0 to pi. But there is a value for which sec x undefined, so that's why we exclude, that is π/2. Last one is cosec inverse x, again the same r minus -1, 1, then taking sine, that is -π/2, π/2, and there is one angle for which cosec x is undefined, since sin 0, 0, that's why we have to exclude 0. This is about principal value branch. Here I wish to discuss if no branch is given, then we mean principal value branch. It means in the questions when it is given evaluate or find, get the value, in that case if it is not given, what type of values are we going to take? So we are concerned to principal value branch. It means we have to take these values only for the given trigonometric ratios. Now come to the graph of the inverse trigonometric functions. Graphs of inverse trigonometric functions. For graph, first we have to discuss the graphs of trigonometric functions, then we have to change the axis to get that. We are starting from, that is sin x. Its graph is this is x-axis, y-axis, taking this one π/2, this is pi, this is 3 π/2, and this is 2 pi. From this side -π/2, and this is -pi. Here it is 1, and here taking, that is -1. Now sin 0 is 0 and it attained maximum value at pi by 2, then again pi is 0 and again 3 pi by 2 minus 1, again 2 pi is 0 and since it is periodic function, that's why this is actually the graph of sine function. To get the graph of sine inverse, we are supposed to change. This is the situation. Actually, this is x-axis and it is y-axis. We are supposed to change the axis. It means now positive x-axis falls on positive y-axis and positive y-axis falls on positive x-axis, and the new graph obtained by doing that, we get the graph of sine inverse, and we can apply it is for all the trigonometric functions. So that's why. Second thing is, either we may use this line y equal to x, then the reflected images of these functions are said to be the graph of sine inverse. Now our principal value branch, if we take whole, that is, it is x, y. Now when we interchange, that time it is 1 and it is minus 1. So now 1 comes here and that is minus 1 and it is 1. This is pi by 2, this is pi, this is minus pi by 2 and this is minus pi. So pi by 2, that is 1. So when we interchange, then we get that is 1, then it is 0, then it is minus 1 and so on. This side, that is minus 1 and it is 0 and so on. This is about the graph of whole sine inverse function. But we are concerned to get the graph in our principal value branch. That's why we discuss only the portion of the graph that fall here pi by 2 to minus pi by 2. It means having no turn. So this portion of the graph, that is from minus, that is it is pi by 2 and it is minus pi by 2. This is the portion of the graph which belongs in principal value branch. So this is the graph of our sin x, and to get the graph of sin inverse x, simply we get that is axis. This is the axis and this is x-axis, y-axis. Now we take, that is there is a change. It is 1 and it is minus 1, and when we change, here comes pi by 2 and here comes minus pi by 2. So sin pi by 2 is what? 1. So we start from here and it is minus 1, and the nature of the graph is like this. It is 0, then it comes. It is actually the graph of sin inverse x for only principal value branch, and it is for whole. By the same way, we get the graph of other trigonometric ratios. So just after sine, we are required to take that is graph of which function? Cos. This is x-axis, y, this is graph of cos x. So here again taking 1 and it is taking minus 1 and it is pi by 2, it is pi and it is minus pi by 2 and it is minus pi. Principal value branch of cos x, cos inverse x, that is what other thing, but here it is cos x. So for taking the graph, we are required to discuss from 0 to pi. Cos 0 is 1, cos pi by 2, 0, then it is minus 1. It is what? Minus 1. This is for the graph for this one. Actually, whole graph is, that is again it becomes 0 at 3 pi by 2, then it comes 0, then and so on. This is whole graph, and for principal value branch, only this portion of the graph is under discussion. So how we get only interchanging. This is y axis, it is x axis. Now when we interchange, then it is 1 and it is -1. Now here we get that is pi by 2 and it is pi. Okay, so starting from here, when we rotate it this way, then what's about the nature of graph? Then for what value it becomes 0? Cos 0 is, that is 1 here, and cosine pi is -1. So starting from here, since this is -1, it is pi, so it comes like this. This is the graph of cos x. Now next ratio is, that is, it is cos inverse x. This is the way to get the graphs. Now tan for tan, we take the compartments, that is what? Its principal value branch is -pi by 2 to pi by 2. It is x-axis, y-axis, origin, and left it is pi by 2 and it is -pi by 2. And nature of the graph is from right top it decreases 0 and it is the graph of tan x. And very easily we get the graph of tan inverse x by interchanging the axis. This is y and it is x-axis. Now this is pi by 2 minus pi by 2, so it comes here. This is pi by 2 and this is minus pi by 2. Now let's get the line. This is pi by 2 and this is again when we change x-axis and y-axis here like this, then what's about the nature of the graph? It take the shape here undefined, so it is 0 and this is called the graph of tan inverse x. Now for the graph of cot inverse x-axis, y, it takes the part from 0 to, that is pi. There is between, that is pi by 2, but pi by 2. So nature of the graph of cot x is, that is from left top when it is 0, this is the graph of what? Cot x. What? Cot x. Using the graph of cot x, we wish to get the graph of cot inverse x. So what's called the change? This is x-axis, then this is y-axis. Now it starts from 0 to pi, so it is 0 and make it pi. What? Pi. In between there is what? Pi by 2. It is pi by 2. When we change it, so it takes the shape this is about cot inverse x. Now next one is, that is sec inverse x. So for sec inverse x, we are required to make the graph again sec, that is it is actually it is minus pi by 2 to pi by 2 and that is 3 pi by 2 and so on. This is y-axis, this is x-axis and origin. This is 1 and this is minus 1. The shape of the graph of this is, that is from this region and it is next it is minus 1, so there is value pi and it is minus 1, so it takes this and next portion is y. So since we wish to get the graph of this function in principal value terms, that is from 0 to pi, that's why. So by using the graph of sec x, easily we get the graph of sec inverse x without any problem. This is the graph of sec x. Now this is y, x is, then it is. Now there is 0 and it is pi. So it is line having that is pi. In between there is a line of pi by 2. This is pi by 2. Okay. So this is 0, pi, and that is pi by 2. Now here we wish to take 1 and it is minus 1. So sec 0 is 1. So it starts from here and it is undefined at pi by 2. So this one. Now what's about sec pi? Definitely sec pi. This is pi and it is minus 1. It is minus 1. That's why it goes to this. This is the graph of sec inverse x. Last one. Now this is the graph of what? Cosec x, and principal value branch of cosec x is minus pi by 2 to pi by 2. So that's why this is 0 to pi and 0 to minus pi, and there is this is 1, this is minus 1. Here we have pi by 2 and here we have minus pi by 2. The nature of the graph of this is like this. This is 1, this is 1, and rest is not a part of its principal function. Next one is this is, that is not the part of the principal value branch. That's why dotted lines and it is minus 1. Now by interchanging its axis, we get the graph of cosec inverse x. It is from minus pi by 2 to pi by 2. Y dash x dash, and it is okay. So this is line 0, and how we change it? So here we take minus 1 and here 1. Okay. So it is like this. This is 1 and pi by 2, and it is infinite. Now what's about minus 1? This is the sigma. This is the graph of cosec inverse x. Okay.